Everybody, this is Todd Frazee again, and this is the probably the final modeling part for this class. It's the S60-147 CAD work for the electronics box. And this is an introduction to sheet metal tools, which is more of an advanced tool. So in some ways this might be one of the more complicated parts. But how this applies is sheet metal is often something that the folding of it may not be automated, but the cutting of the what's called the flat pattern before you do any bending is done on CNC. So this will be actually one of the last parts you model, but one of the first parts you program. And this part could be cut on a CNC laser, a CNC water jet. The laser would have to have enough wattage. You could cut it on a plasma cutter, but for the nature of this sheet metal part, plasma may not be the preferred due to the looser tolerance and the amount of melt dross you get on the back of the parts. So this is a fairly small part. It's a little electrical can basically with a hole for a USB port and for a LED or light pipe in the face of it. Alright, so we're going to develop this model as a solid is shown, and then you're going to use the sheet metal tools to do so, and then that'll allow us to unfold it and make a flat pattern. So if we look at our drawing, the first page has all the detail you need to model the part in the folded configuration. And then if we look at the page 2, it shows the flat pattern of the sheet metal that would create that part as a flat pattern, and we would use the exterior perimeter of this and the holes geometry to drive your cam around. Now those cutting machines tend to be not too precise on holes, so this little 1/8 inch hole here, you probably in real life would either punch it or use a drill bit to come back, but it still would be an operation that could be automated through CAM. So the end result for CAM is really this page here, page 2, is you'd export the outside profile. And but let's get going without any further ado on the model itself. And we're going to go to SolidWorks. Okay, so we're going to open a new part as usual. And I'm going to go ahead and save that part. And I'm going to call it the 147. And before we do anything, we're going to right click and pick on Toolbars, and we're going to make a toolbar that's not visible by default, and that's the sheet metal. Okay, it defaults to throwing it over here on the left edge. If you're going to use it a lot, you can add it as a tab up here at the top through your configuration, but for today we're just going to run with it with the default settings we have here at the lab. Okay, so for any sheet metal part, or any part for that matter, you have to start off with a base feature. And that base feature could be just an extrusion. But we're going to use this tool here called Base, Flange, or Tab. And what this does is allow you to draw a two-dimensional outline of your part and add thickness to it. So it's a very quick way to trace the profile of the part, a major profile of the part as it would have been bent. Okay, we're going to make our planes visible. I guess it's the bottom or top view in this drawing. Let's do that. We'll draw on the top plane. That's the way, same as our drawing. So we're going to go to the top plane. We're going to hit Sketch, and we're going to go back and reference our drawing. And our dimensions are called from, in the top view, it'd be the bottom right corner. So we're going to draw a line that starts there. It's going to go up. It's going to go. And it's going to stop there. And then we're going to draw another line that goes from the bottom. It's going to go left. And it's going to go up and stop there. What we're doing is we're leaving an intentional gap where we would have our final fold over to make the entire shape. So we just want a box, but we're going to leave some spacing here. Okay, so let's throw some dimensions on this. Our box is 4 inches wide by 3.5 tall. Okay, those are our major dimensions. Now, we want to have, according to our drawing, we look at the top view, we have this sheet metal part come over, bend over, and it goes over this other part. So we need to have a a gap here. Okay, so, and it needs to be about a material thickness. Okay, so we're going to make the dimension on the left leg 3 inches 450 thousandths. So we want to make it shorter. So we're leaving 50 thousandths of clearance there for a bend radius. And then our top dimension is going to be 300. It's going to be basically 4 inches minus 24 thousandths, which is going to give us 398. If we go to 3-bit place decimal points, it's actually 397.6. Okay. That's based off the sheet metal thickness and our sheet metal being offset from the outside to the inside of the part. So again, these are going to get thicker going in each subsequent direction. But the overall outside dimensions of the box are going to be maintained at 4 inches by 3.5 inches. Okay. All right. So we've now made our sketch. We're going to accept our sketch. It's fully constrained. And then we're going to go to our sheet metal command. Overall height of our part is 1.25 inches. Okay, in one direction. We're not going to use the gauge table. Our sheet metal parameters is 0.024 thick material. Okay, and we're going to use K factor with a bend allowance of 0.44, which is for stainless steel of that thickness. And our bend radius is going to be 1 material thickness, so 0.24. Okay, we're going to accept the relief ratio. It's going to make its own relief, and it's set at 0.5 of a thickness. So that's pretty much all we need for this, and we're going to hit accept. Okay, so we've now made our base flange. As you can see, it's created thickness on our material. And it's offset to the inside of the lines. Okay, so there we go. All right, now we need to add flanges for the things that bend over the edges. So we have flanges on both sides of the part. They have a different width. So the ones on the top side that we're looking at are 1/4 inch wide and 3/8 or 380 thousandths on the bottom. So let's go back to our model. And we're going to now have these other commands that are available. So we're going to use the edge flange command first. So we're going to select edge command, and we're going to select the inside edges And we're going to select the inside edges of our box. And I don't really like this, but it wants to keep going to defining the overall length of the flange right after you've selected. But if you have multiple flanges to select, you got to keep picking this flange parameters box. Okay, so our default radius is 24 thousandths. Our gap between our folding parts right now is set at 10 thousandths. We're going to have an angle where they overlap of 90 degrees, the bend angle is 90 degrees. And the flange end is going to be blind, and on this side it's 1/4 of an inch, so 0.25. Alright, and so it automatically will put in the bends, the bend relief, and a 10 thousandths gap in between. And you have trim side bends. You can select different places for the bend selection. The default I have keeps the box at the overall height of 1/4 inch, is what was originally selected. And there's some custom parameters you can set, but we're going to leave those as default. Okay, so you should have a yellow preview of all 4 sides of the flange bending in. We're going to accept that. Alright, and we have a slightly larger gap on this side, which is where we're going to add a flange where this is either riveted or spot welded together. And that extra space will give us some adjustment room to work with. Okay, so we've got our bend release in the corner, and our base flange already had the radiuses bent in it. Okay, now let's flip the part over and look at it from the other side, and we'll put our wider flange on this face. So we're going to go back to the Flange tool again, and we're going to pick on the inside edges again. Let's try holding the control key down while we're selecting these. No, it doesn't make any difference. Kind of annoying. Okay, so I got my 4 edges. We're going to set our width of flange at 0.38, which is what our drawing says. So we should have similar flanges to what we have on the opposite side. They're just a little bit wider. They should all face in. If you have trouble with what direction they're facing, you pick on this, double click on the arrows, double click on the arrow, and it'll change directions. And we're going to accept that result. There we go. So we got our bends in the opposite direction. Now let's return to looking at the top of the part. We're going to do our last flange. It's going to be here on the edge. It's going to flip around the corner here. It's probably a good time to save. Okay, so we're going to go to the Flange tool again, and we're going to select on the inside edge. And here we don't want it to, interfere with the side of our part. So let's go ahead and click to give it a direction. We're going to do bend outside, and what this will automatically go to the outside of our box. And then we're going to add on an offset, and that offset is going to be 0.01. And what that's going to do is going to leave a 10 thousandths gap for tolerance for us to make adjustment. Okay, and the width of our flange is going to be, according to our print, 1/2 inch. So 0.5. Okay, so you should have a flange sticking a 1/2 inch out from our material. Okay, we're going to accept that. And we've got our flange. So we're either, when you fabricate this, we'd either drill a couple holes through here and rivet it, or if you can get a spot welding tip in there, spot weld it in a couple places. Okay, that's it for the actual sheet metal commands for fabrication. Now we need to just do some plain old extruded cuts to put the rest of the features in. Okay, so always a good time to save. And let's look at our drawing. We have a square hole and a round hole to put in the front face. So that is the face that has the flange on the left and the welded flange on the left, and we're looking at the front of the box. So the thicker bent flanges are going to be on the bottom. We're going to start off with a rectangle. Okay, so we're going to sketch, and I think we have it orientated correctly if we just pick on the front face. We have the correct side of the part. We're going to look at the model normal to that sketch, and we're going to draw a rectangle. Okay, we're going to accept that rectangle, and then we're going to go ahead and draw our circle off to the left. We're just going to go ahead and do this in one feature. Okay. So let's give our box a width, and let's see what that width is on the drawing. It is 580 thousandths, so 0.58, and its height is 260 thousandths. Okay, and the circle is 0.125, or an 1/8 inch in diameter. And then if we look at our drawing, the box and the circle center is 740 thousandths from the base. So that's on center line. So let's mimic that in the model. So if I take a center line and go from the center, the midpoint of our right side of the box, and draw a center line horizontal, I get that result. And if I take the center of our circle, hold the control key down, and highlight the end of our center line, we can merge those points. Okay, and then we have a dimension that goes from the bottom of the part to that center line, which is 740 thousandths. So we're going to take a dimension from the plane to our center line and over. We're going to type 0.74. And then we have dimensions that give the spacing. So our spacing between the right side of the box and the hole is 181 inch 800 thousandths. So we're going to go from the right side plane not sure what's going on there. From right side plane to the hole, which is 1 inch 800 thousandths. And then if we look at our rectangular cutout, it's 1 inch 20 thousandths from that same edge to the right edge. Alright, everything's black now. should have a fully constrained sketch. We're going to accept that sketch. We're going to look at it a 3D view. And our drawing says that cutout goes through just this one wall. So we're going to go Features, Extruded Cut. And we're going to change it from blind to through next. So it's just going to go up to the next surface, which is the back side of the sheet metal. And we're going to accept that. Okay, so we've got our hole.